Instrumentation, and we gotta talk as fast as we can, so let's get close. Okay. Sorry. Left. Go all the way back. Yeah. He's gonna try. So, we do have a PowerPoint over here. We're gonna stick to that pretty loosely. I think it's a little bit more important to walk through the plant. You're gonna see everything up here, and the data's all up here. This is Water Expert. So it's, oh.
What you gonna do?
Here we go. Oh.
You broke it. Oh, damn.
That was Water Expert.
Yeah, still is.
Okay. So this is Water Expert. Now this is we have a modem in here, and it's just throwing data to the cloud, to our CRM online. And so we can log in and look at the data from this plant. This just happened a few seconds ago. So we're gonna show you this stuff in real time. You know, maybe a few second delay. But what we want to show you here today is, first of all, this is a small skid plant. This is an actual plant. It can treat water. It did somewhere else. I don't know where else.
It was in Shelby, Washington for about 2 years.
It was in North Carolina for about 3 months.
There you go. So this is an actual small plant, and it is doing everything that we do to operate and treat wastewater right now. Just obviously, because we're all here, we're not treating wastewater, it's just bleach water. So what we want to talk about today is air entrainment and bubbles in the piping system, because we've learned the hard way that it can affect literally everything in our permeate piping system here. So right now we're running the system, and you can see we got a full pipe. We got a full pipe. This is our suction pump.
Okay, it's simple setup for demonstration purposes. There is a membrane in here, and we've got air on the membrane, so I've got a screen. We're pulling out of this tank and through the pump right back into the tank. In the inline instrumentation, turbidimeter right before we leave, go back to the tank. Pressure transducer, we are calculating TMP. And a mag meter, flow meter for the permeate flow. And not instrumentation, but we've added a small valve with a 1/16 orifice on it. We can simulate loose some type of leak or way for air to get into your permeate suction site system.
Yeah. We are simulating a hole. That's what we're doing. And we're using a hole to do it. But, so, anyway, what we've got going here is the system is stable. Like I said, the pipe is totally full of water. But what we're going to do is we're going to introduce air into this system and show you the before and after effects of what happens when you have air in the system. So, if we look up here at Water Expert, you guys can see that we're watching permeate flow. Again, this just happened a few seconds ago. If we look at that permeate flow, it does what we like to see. It just spikes up a little bit, and then it finds that flow, and it just is a stable, straight line. Turbidity is the same thing. It's a very low turbidity number. It's clean water, obviously. But it's just a stable, very low, straight line. You want to scroll up and show what else we got? We've also got TMP, and we've got TMP permeability and flux over here. So those look a little bit wild, but we've taken off all the filters and all the PLC smoothing, because we want to show you this in real time. We want you to see the effects. So your plants probably don't look like that unless it looks like this once we open this up. So they're not as straight, but you'll be able to see the difference once we do this. Okay, so that pretty much summarizes the equipment that we have here on the skid. And why don't we show the machine? Make a hole. Okay, we're going to make a hole. Come on, hole. Look at this piping. And by the way, if you guys can't see it, feel free to walk over here and take a closer look. What's going on here? The pump's still running, full suction on the piping. The water is flowing that direction, but we're bringing air in through this hole. So again, we didn't properly glue these joints. There are joints everywhere along the pipe. We didn't. We pinched the little O-ring inside of this connection. did tighten up a flange somewhere. That's what's going on here. We're just introducing it. So again, this is an actual operating plan. Right now we're just going into relax. So we're stopping permeation for a moment. And as you can see, we've got air bubbles going through there. It's pretty clean right now, but once we get it going again,
It showed.
you'll see the difference.
It showed that quick.
So if we look at turbidity here, just by introducing a little bit of air, it now looks like we have a breach in our membrane. It looks like sludge is coming in and going through our turbidity. That's what turbidity is there to show us, but we know that's not the case. There's no sludge to do that. So what we want to show you here is that air bubbles going through a turbidimeter will have an effect and raise your turbidity. And that can get really, really high too. So that's a pretty small change right there, but once the system's running again with that air coming in there.
There we go.
And another thing to note as well, that pipe was empty right there. It just totally drained out. A tiny little hole that big means that when you come in the morning and your plant's been in intermittent mode, you have to reprime that piping. We have a pretty simple prime situation here. We have a positive displacement pump, but that's not true in most of our plants. So if you have this issue, you might have a fight when you show up trying to reprime your piping, especially if you raise it. If you got to bring that liquid up 15 feet or something like that, then you're going to have a hard time. So what we can also see here too is on our permeate flow, we had a nice straight line on the last permeate cycle. We were able to control that flow very, very well. This cycle is starting to look totally different. We need a little bit more time to pass native, but you can already see the effect on permeate flow. Now, what's that going to do to our PLC and our pump? We're basically telling our PLC that our flow through the through the flow meter is going up and going down. And we would see that even if we had the pump locked in a manual flow rate, or I should say a manual pump speed to be more specific. Even though we're not changing the pump speed, we would be seeing different flow rates. And the reason for that is, you want to go to the flow meter slide? Sorry, thanks Doug. The reason for that is that the bubbles do not conduct electricity. So the way the flow meter works is it's conducting electricity from one probe to the other. And in doing that, as the flow increases, it has an effect on the reading that thing gets. And it's set up and calibrated that way so that you can get a flow reading just using electricity. When you have bubbles going through there and it keeps interrupting that electrical signal, you get readings that look like that. So, another thing that we want to look at is the suction transmitter over here. You go to that, Todd?
Right there, yeah, gotcha.
There you go. Our TMP reading, actually,
Doesn't really do
it
anything.
actually still looks pretty good on our
Because we have no
TMP.
membranes.
Oddly enough, but because that air is compressible, you know, water does not compress, but air is compressible. So it can have an effect on the system that's doing this, and it'll also have an effect on our TMP readings and our transmitters.
Kind of hydraulically, the cumulative effect of what's going on is when this pipe is, full third of this pipe is being taken up by an air bubble. So the consequence of that is the pump's got to work harder to pull the same flow through a smaller pipe. And in addition to air bubbles messing with the magmeter's ability to read accurately, is that pump is choking on air as well. So this sort of accumulation of error just has things going all over the place, which absolutely with the centrifugal pump. Yes. Yeah, when I say choking on it, in my mind I'm thinking centrifugal pump. Yeah, this PD pump is just going to turn it in. And that's also why we didn't have to reprime the pump when we stopped. Alright.
So,
Yeah, bring it
we'll see this again too. If we look at our trends up here, now he's closed it up. We just wanted to relax again, but we're still holding this air in here. It's locked in here. If you find a small hole like that, suddenly you don't have a fight anymore when you show up in the morning. So it's really, really important. How much time? Do we know how much time we have?
We're running faster this time, I think.
Okay. Let's see. I feel like I'm running through this as fast as I can. So.
Well, you already run through the first time, and now you get quicker.
Okay. What else do we have to talk about?
Bubbles.
Show me out, Dad.
When you went through the leaks, the most common areas of the leaks, you went through that. So,
Yeah.
You stole my thunder. I'll let you run. Talk about that.
Okay. Came up last time as well.
Yes. This is my favorite.
Yes.
So,
Yes, it is.
During startup, we
Over there.
we can't force
While we're doing integrity test.
pressure test and pressure decay test, all the things that we'd like them to do to make sure that the piping integrity is solid. But even if they do, I said that. Even if they do a pressure test, it might pass like a pressure decay test. But if you've got a suction lift system, especially if you're pulling, several pounds of vacuum, there are leaks that can open up under vacuum that won't. Things that'll seal under pressure that'll open up very good. And engineers want to jump through the phone and murder me when I say that because they're like, well, how do I check for that? And that's kind of one of the battles. But we've got, I think we're coming up with some pretty creative ways to sort of check that out. But yes, absolutely.
Okay. So again, now that we've been running a little bit, if you look at our trends up there on the wall again, you can see our permeate flow is stabilized. We found the hole, we fixed it. We now have very good control of our flow rate. We can hit that flow rate dead on. Same thing with our turbidity. Our turbidity suddenly drops right back down to where we want it to be. Straight line there. The suction pressure would also have the same effect too. Todd's going to bring it up there.
There it is. Looks the same.
I'm getting concerned about how much time we have left, and we do have to ask a few questions here.
Yeah.
So we'll go to it.
I think we'll pass it.
I'll pass it.
Maybe you didn't.
Did I just give them the answers?
Probably. There you go.
There we go. Okay, so we are trying to offer some credits here, so we have to ask a few questions. So, anybody can jump in here. Let's start with number one. What instruments are affected by the bubbles?
Turbidimeter, flow meter, and
Turbidimeter, flow meter, and suction transmitter, right? Okay, and again, it's literally everything on this suction line. Air. Oh, and another note too, we didn't talk about where air can come in this aspect, so I want to point this out as well. You got to remember too, we're scouring the membrane all day long. Every drop of permeate that goes through there comes through while we scour. We are putting dissolved oxygen into the system in our pre-air system. That dissolved oxygen comes in with the permeate. So even if this thing is tight, it doesn't matter. If you want to come up over the wall like that and back down, when you go into an intermittent and the flow stops, that dissolved oxygen will come out of solution over time and start to build up, and it'll raise up to the high point like we have up here, and you can see it in that pipe. So it's going to get there, it'll show up. It doesn't matter if your piping is tight or not. Obviously if it's not, you're going to have a bigger problem. But that air will build up there, and you will see the effects on this equipment if we don't have a way to get that air out of the system. So I do want to point that out. Number two, can you give me 3 potential effects on instrument readings caused by the bubble? What do we see?
What's the one thing that normally...
Shout it out. Turbidity rise. Here it is.
turbidity? I couldn't hear you, I'm sorry.
It was correct.
No. What do we have? Turbidity?
Turbidity increases and flow fluctuations.
Suction pressure. Good job. Okay. Number 3 is how can the bubbles impact instrument readings and PLC calculations?
Supposed to be running a flow of 100 GPM, will or will or not? Clue.
No.
Your flow and pressure affect your transmit rate count, so what do you think your valve is?
TMP is off. TMP is artificially inflated.
So,
that's exactly what it is.
Okay, there's some examples. Let's see. So again, I don't think I pointed this out on this one yet, so I'll say it. I might be saying it again. But the thing about what we see here is it's misleading. You know, when we have air through there, we may be affecting the flow, but we also may not. It might just be some small bubbles, but we're still going to get a very fluctuating reading. So it's misleading. You guys are going to call us and say, hey, I got permeate flow deviations. And then we start looking into the control system. Why is the pump speeding up? All of this, it's very distracting. You can look at all the wrong stuff, and the answer is you have bubbles. So even the same with the suction pressure. It's compressible, and it also affects, again, the pump speed is going to vary like that. All that stuff has an effect on the suction pressure as well. Same thing on turbidimeter. When you see that turbidity shoot up like that, you're going to say, oh no, we got a hole. We got a hole, we got sludge coming through here. And then you go look at that sample and it looks gray or you know, it looks foggy. You're like, what is this? And you set a sample on the table and it's perfectly clear after a couple of minutes. So you know that the water is not dirty, but we've been misled all along the way, and it has affected literally every piece of instrumentation and equipment that we have on this permeate suction and discharge line.
So in a hot water system, like a boiler feed system, put a degasser in line, try to get that stuff out. You ever tried that?
We try to have not holes in our pipe.
That's a good first step.
I missed the question.
He said that in boiler systems they put in a degasser.
Because the same thing happens with changing the temperature and pressure
Yeah.
in boiler feed systems. So the dissolved gases come out of the solution too. You gotta have
Yes.
a fancy air release valve basically.
Well, exactly. To that point, that's why we install those ASCO Red Hat valves that everybody loves so much. Those are there to relieve the air. You put them under we put them under a point of positive pressure, and so that way we open those solenoid valves and we release the air that way. However, we've had some trouble with those valves.
It's leaking back.
Yep.
Yeah, I'm telling you this word. Diaphragm is more.
Yep. You guys have any questions? All right. Well, feel free. You can get up and take a closer look at this stuff.
Yeah.
We're ahead on